let's see an example of expected value. So I jokingly start here. We have the opportunity to lose money at a casino because that's what happens on average, right? And that's what the expected value tells us. It's not what we expect from a single probability experiment or a single game, but it's what we would expect if we played the game over and over again. So the average result. So the game is we pay $4 to roll a fair six-sided die, and then we receive money based on the result. So the game is we roll a die, and then we get some money after we pay $4. Let's find the expected value. Now remind yourself the expected value equation is the sum of events multiplied by their probabilities. This is the exact same thing as a weighted average, right? I weight each one of my events with the probability of that event occurring. And then that gives me my expected value, right? So if X is a really popular event and the probability of it occurring is high, and then Y is a low probability event, my expected value is going to shift more towards the X. Okay, so when you're finding the expected value, it's important to know, what are you finding the expected value of? Are we finding the expected value of the roll on the die, or how much money we think we're going to make? So we are trying to find what? The expected value of how much money we're going to walk away with, right? We're trying to find the expected winnings. So in our equation here, these will be the dollar amounts. And then we'll take our dice and give ourselves the probabilities. So the expected value is the sum of all the different possibilities for the winnings multiplied by the probability of us getting that winning. So the first amount that we could win, let me clear off the table. The first X value is $10. Right? We could win $10. And then what's the probability of that happening? It's only 1/6. Right? So that's my first X times P of X. Now I will add the next event and its probability. So you could win $4. And the probability of winning $4, it happens when you roll a 4 or a 5. That's 2 events out of the 6, or 1/3. All right, we'll add $1. And the probability of getting $1 is either a 1, 2, or 3. So that's 3 out of the 6, or 1/2. So what we get when we go through this, 1.667 plus 1.333 plus $0.50. So the sum, when you add these up, you're expecting to win $3.5. Right, so notice this is important about the expected value. If you look at the possibilities of playing a single game, you can't win $3.5. So it's not what you expect after a single play. It's what you would expect after you play over and over again. Right? You're going to get 10 sometimes, you're going to get 4 sometimes. And then at the average of all those results are going to be, you get $3.5 every time you play this game. So if you pay $4 to roll this dice, so let's put a negative in front of it because you lost that money to play. But then you expect to get back $3.5. Then on average, every time you play this game, you're going to be out $0.50 or 50 cents. So don't play this game, right? You might win sometimes, but why would you play this? It's not likely that you're going to walk away with money.